In the last video, I introduced you to the concept of what a network is and some common terms like LAN and WAN and local resources and remote resources. And I threw a couple of terms at you like network interface cards and routers and switches. So now I'm going to go a little bit deeper into what makes up a network. What are some of the actual components that we need to put a network together? What are some common things you would see, whether you're talking about a little network like the one you have at your house, or a large network at a really large enterprise business? What are some things you would see in both those types of networks? So what would you find on a network? I'm going to talk about each one of these individually. Well, you're going to find servers and clients. That's the whole reason we need the network, is so clients can access those servers. And so one server can talk to another server. We're also going to have local resources versus network resources. And I covered a little bit of that already, but I'll cover it in here also. Network hardware components. When I talk about this thing called a network infrastructure, what is that and what do I actually need to buy? What can I touch and feel and see that makes up the network infrastructure? And software, right? There's something called network operating systems. And what is a network operating system? What type of device uses a network operating system and why do I need it? So let's talk about each one of those things. So servers and clients, like I mentioned earlier in the previous video, a client is typically a device that is making a request for data, okay? And it's a device that you as the end user are holding in your hand or looking at in order to do your job or to entertain you. So these are all examples of clients: your laptop, your smartphone, your tablet, a desktop PC. These would all be examples of clients. And by itself, without a network, you still can do some things on clients. For example, on a laptop, you still have word processing ability. You still might be able to bring up a spreadsheet or create a spreadsheet and save it locally on your device. But you can't exchange data. You can't get data from something else without a network. So the clients have to connect to a network, and typically speaking, in most networks, clients are talking to servers. Clients do have the ability to talk to each other. That's something called peer-to-peer networking. But most of the time, clients are communicating with servers. And like I mentioned in the last video, a server is like a client. Physically, it might look the same, but a server has a lot more memory, a lot more processing power. The brain or CPU or intelligence of a server is much faster, much more powerful than a client. So for that reason, we can store a lot more data on a server and we can access that data much more quickly on a server. And also servers give us a lot more control over that data as far as securing it, providing permissions as far as who can get to that data and who can't, who can add data to the server and who cannot. So servers give us a lot more flexibility with that. So in most networks today, even your home network, when you access the network, your purpose from your client side is to access a server, to get some information stored on that server. So local and remote resources. So local resources are things that are built into the client device itself. Things that, a resource that you could take advantage of, that you could use, that doesn't require any network connectivity at all. So for example, your own hard disk drive, that's what HDD is, hard disk drive. When you're saving something to your hard drive or you're pulling up a file from your hard drive, you're making use of what we call a local resource. The memory within your smartphone or your tablet or your laptop, that is a local resource. For example, as I record this, I've got a 7-year-old son and he has a tablet. And a tablet is rather reserved on its memory. It doesn't have a whole lot of memory. And he's starting to discover, because he's got about 10 gazillion songs on there, that he's running out of memory. And so I'm trying to explain to a 7-year-old, okay, the memory is the part of your tablet that is storing the songs that you've downloaded. And you've got so much information on there, you don't have any more room. Your tablet doesn't have any more brain power to store that music. Now in a server, servers have like 50 times as much memory as a client does. but a memory would be considered a local resource. Your keyboard and your DVD-ROM drive, right? These are all things that are locally connected to you that you can utilize without being connected to a network at all. Versus network resources are like networked hard disk drives. You know, when you go to ine.com or cnn.com, what you're doing is you're sending information, you're sending a request to a server somewhere, and you're saying, hey, server, on your hard disk drive, you've got some data, which is a website. You've got images on there, you've got text on there, it's stored on your hard disk drive. I want to access your hard disk drive, get that information, and download it so I can display it on my monitor. So you're accessing a remote hard disk drive, so that's considered a networked resource. Certainly network printers and network optical drives are connected to network servers are also considered aspects of networked resources. All right, so what are some other common components? So we need to connect to the network somehow. There has to be something physical on our laptop, on our tablet, that gives us a connection to that network. And that's going to take one of two forms. Either it's going to be a wired connection, where I actually have a wire I can pick up and hold and bend and twist, or it's going to be what we call a Wi-Fi connection, something that's invisible, that uses radio waves. Either way, your client, your host, your smartphone, your tablet, your PC, has to have something called a network interface card. And you'll typically see this referred to as a NIC, a NIC. So a network interface card is the hardware component within your smartphone, your tablet, that connects you to the network. So that network interface card might have a hole in it that allows you to plug in a cable. Like these are examples here of network interface cards that allow you to plug into a cable. And these jacks are standardized. For example, this type of a jack right here is called an RJ45 jack. For those of you who like to know acronyms, that stands for Registered Jack 45. So there's somebody that actually came up with a document for this interface that says how big it's supposed to be, how many electrical, pins are supposed to be in there, how deep it's supposed to be. So this is a type of a network connection. Here, this is also an RJ45 connection. This on your laptop is an RJ45 connection. So these are all, so behind this opening, there is a physical component called a network interface card. This RJ45, this network connector right here, is just the outward part of the network interface card that you can see. And clearly the network interface card connects to some cabling. Okay. So in this particular case, what I'm circling right here is an example of typical what we would call Ethernet cabling. Ethernet is a type of cable, and it's got these connectors are RJ45 connectors. So they connect directly into this hole right here. So that's one way you can connect to a network. Now, RJ45 and Ethernet are not the only kind of connectors, not the only kind of cables that can give you access to a network. For example, here's another one. Coaxial cables. So you might recognize this as a cable modem that you got from your cable provider. And this end of the cable modem right here. So we've got our RJ45 jack, so that's going to connect back to your laptop. So your network interface card is going to go into this. And then this right here is connecting to your WAN, connecting to your wide area network. But it's not using an Ethernet cable. It's using a different type of a cable and a different type of a connector called a coaxial cable. And you've probably seen these before. Actually, this is not a good example of a coaxial cable because the ends are, well, it kind of is. But that connects to the wall plate on your house, on the side of your wall. So this is also providing you network connectivity, just with a different type of connector and different type of cable. And then, of course, these days, what most people are used to is Wi-Fi components. So we've got Wi-Fi NIC cards. So a Wi-Fi NIC card actually has a little radio built into it. A lot of people don't realize that, but when you're driving in your car and you've got a radio, well, a lot of the same components that are in the radio in your car or in your office that's blaring music at lunchtime is found in the network interface card that's a Wi-Fi interface card. It's got a radio in it that's capable of transmitting and receiving. You see, the radio in your car isn't really built for transmitting. It's just built for receiving. That's why when you're driving along, you can receive different radio channels, but you can't really connect a microphone up to it and transmit anything out of that kind of a radio. But the radio in a Wi-Fi NIC is bidirectional. It transmits upstream so you can push data out, so you can send out your emails. It can also receive data downstream so you can get your emails, you can get your website and your web page. Most Wi-Fi NIC cards you can't see. Visually you can't see them. If you held up your laptop or your tablet, you wouldn't be able to see because it's built into the device behind the protective casing, behind all the plastic and everything they use. For example, on the right here, we have an example of a Nexus 7 tablet that's been opened up, and you can actually see the Wi-Fi NIC card and the antenna is on the inside of it. Sometimes when you buy a desktop PC, like a tower PC, that doesn't come with a Wi-Fi NIC card, you might want to buy a Wi-Fi NIC card separately and insert it into a slot. So this is an example here of another type of Wi-Fi NIC card. In this case, you can see the antenna that's coming out of it. So a Wi-Fi NIC would be composed of a radio inside of it, and that radio is connected to some kind of an antenna. If you're talking about a smartphone or a tablet, you probably don't see the antenna. Or your laptop, you don't see the antenna, but it has one. For example, a lot of laptops, if we think about the structure of a laptop, here's my laptop, that's the screen, and here's my keyboard. A lot of laptops actually have the antennas built into the screen, like into the side of the screen. So if you hit the side of the screen here with a hammer, not only would your screen black out, but you'd probably also lose connectivity to the network because you've just destroyed the antenna that's built into that laptop. And clearly here in this tablet, we can see the antenna is built on the inside. So very rarely these days will you actually see an antenna. The antenna is usually built into the device. So our host devices, right? Our host devices have some sort of network interface card, either wired or Wi-Fi, that then connects to the network via either a cable or via radio frequencies. Now, what exactly are they connecting to? They're connecting to what we call the network infrastructure. So the network infrastructure is all those specialized network devices that you buy to connect one LAN to another LAN or to create the LAN. So for example, usually one of the very first networking devices that clients will connect to is a switch, a network-based switch. So switches are designed for wired connections. So if I have a whole bunch of people sitting with laptops, in one cube after cube after cube, those laptops have a NIC card connected to a cable, and that cable is terminating on a wall plate or a wall jack somewhere. Well, behind that wall plate, there's another cable. So imagine all these cubes, all these offices have cables snaking out of them, and those cables terminate in a network switch, which is what we see here. So the size of the switch just depends on how many devices you need to connect to this. You can see there's some small office, home office switches that just have 8 ports, all the way up to monstrous switches that can have hundreds and hundreds of interfaces. And clearly their price varies as well. A small 8-port switch, you might be able to get that for just $30 or $40. Whereas this type of switch right here starts at a list price of around $50,000. So everything in between. So a network switch is usually the first thing that, when you're talking about a wired device, like a laptop or a PC, that wire that connects to the NIC card on your laptop or PC, on the other end is connecting to something like this, connecting to a network-based switch. What if I'm talking about Wi-Fi? Okay, well, if I'm talking about like a tablet or a smartphone, well, then in that case, your NIC card is doing radio frequencies, radio waves. What is it talking to? Well, it's talking to another type of device called an access point. So Wi-Fi access point has a radio built into it, typically much more powerful than the radio in your client device, in your smartphone or your tablet. And this is what's talking. You are sending and receiving data from this access point. Now the access points come in various different shape factors. You can see here some of them look like circles, some of them have visible antennas on them. Usually you'll find them on the ceiling or on a wall somewhere. A lot of times in companies, the access point will actually be hidden. It'll be like above the ceiling tiles so people can't see it, so people can't get to it and mess around with it. Now the access point, if that's all you were connected to, if I had a bunch of laptops, all with Wi-Fi NIC cards, a bunch of smartphones and tablets, all doing Wi-Fi connecting to the access point. If that's all my network consisted of, those devices could talk to each other via Wi-Fi by sending information back and forth to the access point, but they wouldn't be able to connect to anything else. They wouldn't be able to connect to any servers, any websites. So clearly, the access point, however it looks, has to be connected back to the network infrastructure. So every single access point out there has one or more Ethernet cables coming out of it, which usually terminate in, you guessed it, a network switch. So these access points have cables going back to a switch somewhere. Like if you're talking about your home network, you've got an access point. That access point most likely has a cable going into your cable modem or your DSL modem. Or maybe if you've got a slightly larger home network, maybe you actually purchased a router or a switch so you could have some wired devices as well as some Wi-Fi devices all sharing that cable modem or that DSL modem. But the moral of the story is these Wi-Fi devices here, these access points, have to have some connection back, some wired connection back to the network infrastructure so they can connect to stuff. Now, if my network was purely composed of access points in the ceiling, in my walls and stuff, my host devices, and my network-based switches, if that's all my network was composed of, then all my devices could talk. I could get to my servers and stuff because they're connected to the same switches with also, NIC cards. But I'd be very limited on things like security. What if I want to divide parts of my network? What if I want to say, well, this room over here, I want it to connect to my network infrastructure. I want to connect to the access points and then the switches. But this room over here can't talk to this room. I don't want data being exchanged between these two parts of the network. However, I do want that room able to talk to other parts of the network. So now what I'm talking about is I have a need to segment my network. I want to be able to impose security restrictions on what parts of the network can talk to other parts of the network. Or maybe I want to implement radically different kinds of cables. Maybe this network over here, in order to talk to this other part of the network, has to use some sort of cabling that a typical network switch doesn't support. Or I just have all sorts of features I want to implement, so I want to really be able to manipulate the data in a lot of strange ways that a switch won't give me the ability to do that. Well, if that's what I want to do, then I have to purchase a device called a router. So that's what routers do. So a router physically can look a lot like a switch. As a matter of fact, I could hold a switch up here and a router up here and ask you to identify which one is which, and you might not be able to tell the difference because both of them most likely have network interface cards, they have cables coming out of them, but physically they look very similar. What makes them different is the inside, what they can do with that network data. So router gives you a lot more flexibility about segmenting your network, imposing security policies, being able to manipulate the traffic, gives you the ability to send traffic in one direction as opposed to different kinds of traffic in a different kind of direction. So to get that type of flexibility in your network, that level of control, you're probably going to want to implement some routers. And then lastly, these access points, these switches, these routers, they all have to run software. They run specialized network operating systems that we call network software in order to be able to do what they do. So the most common type of network software is Cisco's iOS. So Cisco Systems is like the leader in networking technologies, and the software that runs on most of their networking routers and switches is called the Internetworking Operating Software. That's Cisco iOS, Internetworking Operating System, or Internetworking Operating Software. So just like your laptop has software, right? You've got probably Microsoft Windows, or maybe you got some version of Apple iOS in your device. Well, that software in your laptop is optimized for like web browsing. It's optimized for word processing and spreadsheets. But if I took my laptop or my PC, which right now has just a single network interface card, and let's say I put in 10 network interface cards. Now, it probably doesn't even support that, but let's say it did. Let's say I had 10 slots, 10 openings in the back of my laptop where I could just plug in all these different network interface cards. And my goal was, okay, I want my laptop now to be a network node. I want devices, I want other host devices to be able to use it to send data back and forth through it. Well, my client operating system, Microsoft Windows or Apple iOS, isn't really optimized for that. It's not going to give me a lot of ability to plug in all these network interface cards and take a lot of control over the data that's passing through it. That's what network operating systems are for, like Cisco iOS or Linux or something like that. It gives you the ability to finally control data that's passing in and out of multiple interfaces on a router or a switch. So we need network operating systems as well, which typically come with these things. When you purchase a switch or router or an access point, usually part of your purchase is you have to select the software that you want running on that thing. And then later on you can change that software, you can upgrade it or downgrade it if you need it to do different things. So that concludes this part of our video called networking components. So hopefully at this point you can sort of visualize beyond your laptop, beyond your smartphone, what is comprising the network. And there are certainly other things as well that can make a network a lot more complex, like firewalls and other things. But a basic network is going to be composed of network interface cards, which is in your tablet, your smartphone, your laptop. Those network interface cards are going to connect to cables or Wi-Fi, and then it's going to connect back to the network infrastructure, which is going to be composed of access points, switches, and routers. So that concludes this particular video. In the next video, I'm going to talk a little bit more about technologies that comprise a network.